Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will learn how to deploy applications onto multiple Kubernetes clusters at the same time using Argo CD. So Argo CD is basically a GitOps based tool and it is very popular in the continuous delivery space at this point of time. So basically, if you look at the traditional or the legacy CI/CD pipelines, there are two parts. One is CI and CD, and CD part is usually carried by using shell scripts or Python scripts, Ansible, or some plugins that are supported by the CI orchestrator. So if you are using Jenkins, probably Jenkins has plugins for deploying directly to Docker or Kubernetes. But this traditional process, although it's very easy to implement, it comes with a lot of drawbacks. And these drawbacks are addressed by using GitOps. In our context, Argo CD. So in today's video, we will not just learn about the multi-cluster deployment, but we will cover the advantages of Argo CD, advantages of GitOps, and how does this help you in the multi-cluster deployment, which includes setup, configuration, installation, everything will be covered in today's video. So please try to watch it till the end. Now, before we start anything, to implement this multi-cluster deployment, of course, we need multiple Kubernetes clusters. So first of all, I'll execute these commands where I will spin up multiple EKS clusters using the EKS CTL. So if you're not aware how to use EKS CTL, everything will be covered as part of the documentation. Don't worry. So I'll also share a GitHub repository which will have all of these steps. So first of all, let's create the first cluster and call it as hub cluster. There is a reason why I'm following this naming convention. I'll explain about that. Then let me create one more and call it as spoke cluster 1. And I'll create one more and call it as spoke cluster 2. Now this cluster creations will take, create cluster, right? Yeah, so this cluster creation will take roughly around 20 to 30 minutes. So let them execute while we cover the theory part and while I explain each and every single step. So let's try to understand the multi-cluster deployment first. What exactly it is and why is it needed? In organizations, usually you have multiple Kubernetes clusters. You just don't have one single cluster where every project or every team uses that one single Kubernetes cluster. No, that's not the case. Usually you have multiple clusters, like one for the developer environment, and then you have one for QA environment, one for pre-production, one for production environment. And apart from this, these are the standard environments that usually every organization follows. But apart from that, there are also developers, probably 10 to 15 developers are working on a feature, and they might approach DevOps team and ask that, okay, I don't want to use the dev QA cluster because we are working on a complete different feature. So can you please give us a new Kubernetes cluster? And let's call this as feature 1 Kubernetes cluster. Similarly, in organization, many people work on different kinds of features. There are different organizations, there are different projects, there are different features. So you might create some feature 1, feature 2, feature 3, n number of clusters. Now, what if there is a particular application? Let's call this application as guestbook. So there is a new version of this guestbook. Let's call it as V2. Previously, all of these clusters or some of these clusters, maybe dev, feature 1 and QA, maybe these 3 clusters, right? These clusters had the version 1 of this guestbook application. Now there is this guestbook version 2, and it is very important to have this new version because let's say the old version has some vulnerabilities. Now, as soon as this new version is available, how to deploy this on one single go to all of these three clusters, right? Of course, you can log into each of these machine and using kubectl, you can upgrade the version. Or if you are using the traditional CD pipelines, you can execute shell scripts or Ansible as well. But our goal today is to learn how to use this GitOps principle based tool called Argo CD. And using Argo CD, we will deploy this new version onto different Kubernetes clusters. So that's why what I've done, I have created three clusters. So one cluster is the cluster where Argo CD is installed, because this can be installed only on a Kubernetes cluster. So usually there is this centralized Kubernetes cluster, and from this cluster, we will deploy these changes onto multiple other clusters. So in our case, we have restricted ourselves to three clusters. So this is the centralized cluster. Using this centralized cluster, we will deploy this to two other Kubernetes clusters. And this kind of mechanism is called as hub spoke model. Now, if you want to understand what is hub spoke model, first of all, there might be people who don't understand what exactly is Argo CD or GitOps. Of course, I have made a dedicated playlist on Argo CD and GitOps, where I have covered in detail about what exactly is GitOps, what exactly is Argo CD, and I've also explained the architecture of Argo CD, plus a hands-on session where if you are beginner to Argo CD, you will learn how to use Argo CD. But of course, because in today's video, we are using Argo CD, and if you are following this video, you need some basics. So that's why I will cover a bit of Argo CD and GitOps, and then I'll talk about this hub spoke model. So if we go back to the traditional CI/CD pipelines, right? How does a traditional CI/CD pipeline look like, or a legacy CI/CD pipeline? Let's take Jenkins as a tool. So in Jenkins, you will write a Groovy pipeline or a declarative pipeline. And here you have bunch of stages. So let's say there is stage one, where you perform the build and unit testing. Then there is stage two, where probably you perform the static code analysis. Now I'm roughly making up these stages. And then you have stage three, probably where you perform your SAST, where you might be using Sonar. Then probably dashed. Then you run your, let's say, end-to-end test cases or regression testing. Probably after that, you build the Docker image. Then you scan the built Docker image, maybe use Trivy or Docker Scout. And after that, if everything goes well, using some shell scripts or Ansible playbooks, like I've mentioned, you just take this container, create the Kubernetes manifest, or take the existing Kubernetes manifest and deploy this onto the K8s cluster. So this is how the traditional CI/CD pipeline looks like. And all of these things here, from here to all of the stages that I've explained, all of these things comes under the continuous integration process, right? Because here we are just talking about build, verifying the built image, right? Till here, we just did that. We are performing some tests on it, and then we are verifying the built image. We are running the security. We are running the scanning. But only in this particular stage, we are talking about the deployment. And the concept of GitOps comes in this particular stage. Now let's try to understand what is the drawback of doing this particular deployments using shell scripting or Ansible. What is the drawback? You might say that, Abhishek, for me, it's working well. I am able to deploy my Kubernetes resources, right? You're talking about guestbook application. In our case, we have a different application, and this application we are successfully deploying using shell script or Ansible onto our Kubernetes cluster, and we don't see any problem. Perfect. Now, let me ask you a question. If you are doing it in that way, What if one of the developers, okay, let's create this scenario where you have deployed your Kubernetes resources onto the Kubernetes cluster. And then what happened is one of the DevOps engineer or one of the developers went onto this Kubernetes cluster and modified a particular resource. Let's say there is a config map. And in the config map, there are some data fields, application properties. And one of the developers went to this particular config map, went to the particular data field and modified, let's say the CPUs. I'm just giving an example. Probably there is a particular field in the config map called as processors. And this particular developer has modified the processors from 5 to 10. Now this config map is mounted to the particular image, and what happened is there is a change in the particular image. Or if you take simple example, there is a developer who went to the deployment.yaml file on the Kubernetes and upgraded the version from V1 to V2. Obviously, you will not notice this particular change because this is a manual change by the developer. Uh, Image change can be even significant, but these kind of changes that I was talking about, the processors upgrade, it is not that easily noticeable. So after 10 days, 15 days, you have noticed that your application started failing. You haven't changed anything. You haven't performed any CI/CD pipeline execution. Let's say this is a production environment. Okay. On this particular environment, you haven't made any changes, but the application started failing after 10 to 15 days because this one developer who has access to this pre-prod or QA environment, any environment, and modified the processors from 5 to 10, because of which the application started behaving odd, and after a while, probably application crashed because of excessive threads, or the application crashed because of out of memory issue. Now, who is responsible for this? And as a DevOps engineer, how will you come to know about these kind of changes? So what is the gist of this entire thing? In a nutshell, if I have to put this, when you deploy your applications using CI/CD process, right? And if you're using shell scripts or Ansible kind of things, of course, you can take a K8s manifest and you can deploy this K8s manifest onto the Kubernetes cluster. But this shell script or Ansible will not be capable of identifying any manual changes that are made by DevOps engineers, developers, QA engineers, or anyone, right? So as a DevOps engineer, you might have created a dev Kubernetes cluster, you might have created a QA Kubernetes cluster, and someone comes to you and says that, hey, my application is working fine on dev, but my application is not working on the QA environment. What did you do? Probably you did not do anything, but whoever has access to this QA environment tweaked something on this QA environment. And probably they did not have access to dev environment, so they did not modify anything. So these kind of changes are very difficult to catch. And this is a huge drawback of the traditional CI/CD process. Now, if you are talking about CI, for CI, the source code and everything is available in the Git repository, right? That is, for the source code or for the CI, Git is your source of truth. Because if someone says that, hey, something is not working on my QA environment, what you can simply do is you can just say that, okay, this is the source. You can see, let's say the application properties is modified, right? You can say, okay, this is the right value of the application properties in the Git. I can see that file. But when I look at the changes or when I look at the application properties on this particular cluster, it's modified. So for the CI, you have a source of truth. But for the CD, you don't have any source of truth. So what GitOps suggests is to move away from this traditional process. Do not use shell scripts or Ansible or Python as your deployment tool, but use tools such as Argo CD, or there are other tools in the market like Flux. There you have Spinnaker. So these are the popular GitOps tools. And What these tools are capable of is, if someone modifies, if we take the same example, right? There is a developer. This developer has access to the developer Kubernetes cluster. And you know, in this particular developer Kubernetes cluster, you triggered a CI/CD pipeline and you have deployed a particular config map. Let's say you deployed config map plus secret plus application. You deployed all of these three things onto the dev Kubernetes cluster, and this developer who has access to it has modified the config map. What Argo CD is capable of is, Argo CD will identify that, okay, you have made some manual changes to it, and the DevOps engineer has asked me to make sure if there are any manual changes that are made by these kind of developers, just revoke that particular change and bring the state back to normal. That is, if the config map had processors count as 5, and if developer is modifying the processors count to 10, Argo CD will revoke this particular change immediately and get this change back to 5. So it's very simple how Argo CD does that. In a high level, if I have to explain you, what Argo CD asks you is, along with your source code, so that is your Java code or Python code for your application, along with that, also put all of your Kubernetes YAML manifests. So it can be config map, secret, application, everything. Put that in the GitHub repository or GitLab, Bitbucket, wherever you are using. And this Argo CD, which is a Kubernetes controller, so it will continuously monitor everything that is in this dev Kubernetes cluster as well as this Git repo. If there is any difference, that is, if the state on the dev Kubernetes cluster is not same as what that is available in the Git repository, Argo CD will immediately revoke that particular change and it will pull the changes from Git and deploy those changes to the dev Kubernetes cluster, right? So it is not just part of your CI/CD pipeline. Of course, initially it is part of your CI/CD pipeline, but after that, it is also responsible for tracking the changes, auditing your changes, monitoring any manual changes, revoking them, and auto healing those changes. That is, automatically it is capable of fixing those changes. So for Argo CD or any GitOps tool, Git is the source of truth. So what it will tell is, okay, anything that is available on the Git, because I have deployed some changes, my DevOps engineer used me, that is used Argo CD to deploy whatever is in Git to the Kubernetes cluster. And in future, if any developer modifies anything onto Git, it is fine. Like if you want to modify the application processors count from 5 to 10, Argo CD says developers, don't modify that on the Kubernetes clusters. Modify that on Git, and your change will implement a CI/CD pipeline. And as part of the CI/CD pipeline, I will deploy the new changes onto the Kubernetes cluster, right? So as part of the CD stage, I will deploy the new changes onto the cluster. But if you make any changes manually, I will revoke them because I am a Kubernetes controller, right? I hope this is clear. So the same principle applies whether it is one Kubernetes cluster, two Kubernetes clusters, or 10 Kubernetes clusters. Argo CD is quite capable. It can deploy onto any number of clusters that we will learn today. And if you want to understand more, let's say that Abhishek, whatever you explained is fine, but I want to explore more about GitOps and Argo CD, then you know where to go. So this I have explained just in 5 to 10 minutes. But here, if you see, there is almost like 90 minutes of videos, all three together, where I have explained GitOps and Argo CD in complete detail, right? So please try to watch this particular videos if you are new to GitOps and Argo CD, so that you will understand these things in more detail. Also, there is a very detailed documentation as part of OpenGitOps.dev. So this is the GitOps standards, where anyone who writes a GitOps tool, it can be Argo CD, Flux. So they have to follow these principles, which I've also covered in the video. Now let's try to see if our clusters are ready. So this cluster is ready. This cluster, what happened to it? Okay, let's see what happened to spoke one. Oh, this is, I have implemented the delete action. My bad. Perfect. So I've re-executed the create option here, and spoke 2 cluster is also ready. Now you might be thinking, Abhishek, what is this naming convention? So you have mentioned the name as hub spoke 1, spoke 2. Okay, so I'll explain what exactly this is. So Argo CD basically comes in 2 modes of deployment. One is called as hub spoke model. So these are the 2 major models. Of course, there are different other ways, but let's focus on the primary ones. So there is hub spoke model, and another one is called as standalone model. What is the difference between this and the other one is, when you have an Argo CD installed on a particular cluster and it is managing that particular cluster. Let's say you have, like in the same example, let's say you have dev environment. This is dev cluster. This is QA cluster. And this is probably, let's call it a staging cluster. If you have an Argo CD instance for each of these environments, let's say there is one Argo CD here, there is one Argo CD here, and there is one Argo CD here. And if each of these Argo CD is responsible only for that particular cluster, then this model is called as a standalone model. Or this is basically a singleton model or single instance model, where each Argo CD is responsible for its cluster. So this will watch the Git repository, this will watch the Git repository, and this will watch the Git repository. So if there is a change in the config map, let's say in the GitHub repository, so as part of the continuous delivery process, this Argo CD will pick up the change and deploy onto this particular cluster. This Argo CD will deploy onto this, and this Argo CD will deploy onto this. On the contrary, that is, there is another model called as hub spoke model, where you have Git, and let's say in Git you have a config map, and someone made some change to this config map. So there can be one Kubernetes cluster, which is called as hub Kubernetes cluster, or it can be called as centralized Kubernetes cluster. And in this hub Kubernetes cluster, you have an Argo CD instance. And using this Argo CD instance, you will deploy onto multiple other Kubernetes clusters. So here, each of the Kubernetes cluster can be dev, staging, production, pre-production. Each of them will not have their individual Argo CD instances, but there is only one Argo CD instance that is in the hub or in the centralized model or the centralized cluster. And this will be watching the changes in Git, and it will deploy onto multiple clusters. So this process where each Argo CD instance is restricted to a particular cluster, we have already learned in episode 3, where I have performed the demo. And this process is the multi-cluster process, which we will learn today. Now you might be wondering, Abhishek, which one is very popular, right? So which one should I actually learn? Which is a very good question. Basically, both of these models have advantages and disadvantages. Let me explain in detail. So if in your organization, there is a centralized DevOps team, where there is one DevOps team, probably 10 DevOps engineers, 15 DevOps engineers, who is managing all of the projects, right? Who is taking care of multiple projects, multiple environments, then it is very easy to handle the centralized, that is hub spoke model, because there is only one Argo CD instance that you have to configure. In future, if you want to upgrade the version of Argo CD, because what is the hub spoke model? There is one cluster called as hub cluster or centralized cluster. in which you have Argo CD instance that is managing deployments to multiple other clusters. All the deployments are taken care by this one single instance. So if you have a centralized team where you have less number of resources, it is easy to manage this model where any version upgrades or any particular configuration changes, even things like taking backups or disaster recovery, it becomes very easy if you use the hub spoke model of deployment. Whereas if you have DevOps engineers, one for the project, or you have multiple DevOps engineers where you don't want to use the hub spoke model, and you want to say that, okay, because we have too many clusters, and if you're using the hub spoke model, the other downside is that this particular Argo CD instance becomes with huge number of resources, right? That is, it has to manage so many clusters. So the amount of CPU or the amount of RAM and the number of object it is managing. Please try to understand, when you have so many clusters, obviously you are dealing with a lot of projects and everything is in one single GitHub repository. So the number of Kubernetes objects that it has to manage sometimes can go up to 50,000, 60,000 as well, because one single instance is managing everything. So there is a possibility of this particular instance is overloaded. And if you are not rightly configuring it with high availability, there are options like shedding, which are advanced concepts, which we'll cover later. But when you are using the hub spoke model, you have to set up Argo CD in high availability mode. You have to configure dynamic sharding. You have to configure things like more number of processors, more number of resources. If you don't want to manage all of these things, you have a single instance model where each Argo CD is localized to that particular cluster. And the downside of this particular model, as I've explained, is that if you want to make any upgrades to Argo CD, or if you want to make any configuration changes tomorrow, if you want to, let's say, move away from Argo CD to Flux, in this model, you have to make changes to each of your cluster. Whereas this model, it's just plug and play. If you want to move away from Argo CD, upgrade Argo CD, or if you want to perform disaster recovery, everything is from one place, right? So these are the two models, hub spoke model, and this can be called as standardized model, standardized model, or localized model, whatever you would like to call, probably standalone. Let us see now if our EKS clusters are available. Hub cluster is ready to use. There is some issue with spoke cluster 1. I'll try to debug that. And spoke cluster 2 is also ready. Let's try to see what is issue with this particular thing. It says creating cloud formation stack operation error already exists. So it says that the cloud formation stack is available. Let's try to fix it. So if you go to the AWS console and if you search for cloud formation, so what happens when you run EKS is, under the hood, it calls cloud formation templates. And it says that there is some issue with the cloud formation template for spoke cluster 1. Let me switch to West 1 region, because that is where I'm creating these clusters. And there is no particular reason why I'm using West 1. I think I'm slightly bored with East 1, so I've just switched to West 1. That's it. So yeah, this is the one. If you see, there is an error as well. So what does it say? The following resources fail to delete. That is VPC. Okay, let's go to the VPC and see if we have enough number of VPCs here. My bad, VPC. Okay, so there are only 4 VPCs. Obviously, you can create one more. Spoke cluster 1. Let's try to delete this particular cloud formation stack. This is the spoke 1 cloud formation stack. Because this was not deleted, the cluster creation was not successful. Now the deletion is in progress. So this is how you debug when you run into an error, right? Instead of just worrying what has happened, instead of directly going to ChatGPT or Google, what you can do is just try to read through the error, what exactly is happening here. And it's very clear. It says that already exists the CloudFormation stack. So I'm trying to delete. And of course, if it doesn't delete, again, I'll try to do something. Delete complete. So now all the stacks are deleted. Let's execute this spoke cluster one more time. Perfect. I think now this will be created. And the next steps would be, once this cluster is also available, what we will do is we will have three clusters, as I've explained. One is this hub cluster, of course, and two others are the spoke clusters. So let's call this as spoke 1 and this as spoke 2. So what I'm going to show you is how to install Argo CD firstly on this hub cluster. And once I install Argo CD, I'll show you how to access Argo CD from the UI. Where here today we will not use ingress and all because we have implemented ingress in last two videos. In today's video, I'll show you how to use node port mode and access it. Because our EKS clusters are created using EC2 instances, we are not using Fargate in today's video. So I'll show you how to access node port because some people were also asking about it every time we keep doing ingress. So Argo CD, I'll show you how to expose it through the UI. And next step would be to add these clusters to the hub cluster, right? Because this Argo CD needs to know what are the target clusters. There can be 2 target clusters, 3 target clusters, 10 target clusters. So I'll show you how to add these clusters to the hub cluster. And then we will log into the hub cluster. After logging in, we will create something called as Argo CD applications. These are not Kubernetes applications. We will create Argo CD files, which are called as application custom resources. And this application custom resources will have all the details on how to deploy to these things. This is what we will do in the demo part once this spoke cluster is up. Till then, I'll just pause this video. Perfect. Now my spoke cluster 1 is also up and running. Because we executed EKCTL parallelly on all three of them, what happens is kubectl will point to the cluster that is created at last or the latest cluster. And so my kubectl will currently point to spoke cluster 1. But if you look at the diagram, we want to implement the hub spoke model where I want to execute Argo CD only on the hub cluster. So for that, we need to switch our context to the hub cluster. What I can do, firstly, let me show you all the context that I have. kubectl config get context. So this will get all the Kubernetes clusters. Some of them are currently I'm using, and some of them are the clusters that I've previously created, and the contexts are not deleted from kubeconfig. We can restrict this particular command using grep us west 1. So these are the 3 clusters that are available in US West 1. And let me switch to this particular thing. So what I can do is kubectl config use context. So now if I just do kubectl config current hyphen context, it will say, okay, you are currently on the hub cluster. So all the kubectl actions that you perform will be against the hub cluster, which I want. So let's proceed to the Argo CD documentation. Argo CD docs. And let's go to the getting started. And all that you need to do is just copy paste this particular thing and dump it here. So firstly, it will create a namespace for us, and then it will start installing all the resources in the Argo CD namespace. So if you want to understand what these resources are, then again, please watch this video because I have explained the complete architecture of Argo CD in the episode 2. It will become too much if I try to explain here. So there are different components in Argo CD such as API server, controller, repository server. We have DEX for authentication, and By default, there is also a Redis component that is for caching in memory data store. So Redis is used for that particular purpose. So all those resources, including config maps, custom resources, custom resource definitions, everything will be created by just running this particular thing. In the past videos, I've also shown how to install Argo CD using operator. I've also shown how to install Argo CD using help. Because this is very simple, let's do this. So now my Argo CD is installed. We can verify kubectl get pods -n Argo CD. All of these pods should be up and running. So still, okay, all of them are up, but the API server, which is the primary component where we access the user interface from, it's still not up. Let's wait for it. Shouldn't take much time. Yes. So now the API server is also up and running. Now what we will do is we will change the API server to the insecure mode. What is that? So typically the Argo CD user interface, if you want to implement in a secure way, there is a HTTPS model and then there is a HTTP model. And if you want to implement HTTPS, then it's a complete different thing where we have to sign up for a certification authority. We have to create a self-signed certificate and we have to use that self-signed certificate with the Argo CD API server. Then we can run this particular Argo CD API server in a secure mode. And to do all of these things, it takes a lot of time. And here in today's demonstration, what our focus is on the multi-cluster deployment model. So what I'll do is I will run Argo CD on the HTTP mode itself. There is no problem in running in the HTTP mode for the demo, but if you actually do it in your organization, we should go with the HTTPS, not just for Argo CD, but for everything. So to do that, what we need to do is, don't worry, all these steps will be mentioned in the documentation, but because I'm quite familiar with it, I'll try to do it without looking at the documentation. So kubectl, just try to say get config maps -n Argo CD and go for this particular config map called cmd params config map. So kubectl edit config map -n Argo CD. And in this particular config map, what we will do is we will add a particular data entry. So this is just to run Argo CD server in the insecure mode. So just do data. Like if you wonder, Abhishek, where do you get all this information? GitHub, Argo Proj, Argo CD. You will get that in the documentation as well. Or you can also come here and in the files, you can search for cmd, this particular file. And here it will show each and every parameter that you can configure, and explanation for each and every parameter is also available. If you just search for insecure, so it will explain you run server without TLS, that is without HTTPS. All that you need to do is just copy paste this one from here, run insecure as true. Now as soon as you save this, what happens is, Abhishek, I have edited the config map, but how this config map or how this change makes my Argo CD run on the HTTP? It's very simple. If you look at this config map is actually mounted. Just do kubectl describe deployment / Argo CD -server -n Argo CD. So you will notice that this config map is actually mounted. The environment variables, all these particular environment variables are read from the config map, right? So if you see here, the environment is referenced from this particular config map. So the field that we have modified, Argo CD cmd param cm, Argo CD cmd param cm. So each of this environment variable is read from the config map. Apart from that, there are other things that are mounted as well, but all these fields are taken into environment variables. So whatever you have updated gets updated in the Argo CD deployment from the config map. So if you do kubectl edit deploy Argo CD server minus n Argo CD and just search for insecure. Insecure. See, this is the new entry that got added. And where is it coming from? Like I've explained, the config map is taken in the environment variable, the config map feed. So now I am running Argo CD in the insecure mode and all my Argo CD components are up and running. If I just do pods, all the pods are up and running, and kubectl get svc minus n Argo CD. My service is also up and running. Now what I'll do, like I've explained, I will not use ingress in this particular video because we have used ingress in last two EKS videos and people were asking how to use node port mode. It's very simple. Just go to the Argo CD server. Just say kubectl edit svc Argo CD server minus n Argo CD. And as you do this, just go down, change the type from cluster IP to node port. So I made this change. Now if I just do kubectl get svc minus n Argo CD, you will notice that this service is changed. This is the service. It was previously learning in cluster IP and now it runs in node port mode and the port is mapped to the node port of your cluster. What does this mean? Basically, now if you go to your AWS and if you go to your EC2, because EKS is running all its workloads on this EC2 instances. So you will see two EC2 instances for hub cluster, two EC2 instances for spoke 1 and two EC2 instances for spoke 2. And we are running it on the hub clusters. So now this particular service or the Argo CD user interface will be available on this particular nodes. You can pick up any of these nodes public IP address. Like let's say I'll copy this public IP address. When you change a service to a node port mode, it doesn't matter where is the pod of this server is running or of this service is running. You can pick up any particular node IP of the Kubernetes clusters. Let's say you have 100 node cluster and you just have one pod that is running on 95th node. You don't have to go to the 95th node IP address colon node port. You can go to any of the node IP addresses. Kube proxy will internally take this and route it. Let me explain for people. So let's say you have 5 nodes on your Kubernetes clusters. Node 1, node 2, node 3, node 4, and node 5. And let's say your pod is running here. And then you have created a service for this pod. And you have exposed this service in the node port mode. So you don't have to access this on the node 3 public IP address colon or the node P IP address colon node port. Let's say node port is 31655. Of course, this will work, but it will also work with node 1 IP address colon node port, node 2 IP address colon node port, node 4, node 5, all of these things because internally all of these nodes are connected in a Kubernetes cluster and there is kube proxy which will manage even if you hit to the node 1 IP address, that request will go to this particular pod. So let's see now if you go to the instance, copy this particular thing. And now let me try to access it on the port. What is the port? 30812. HTTP is 30812. HTTPS is 30697. But I'll use HTTP. And of course, this will fail because we haven't opened the security group. So now let's go and open the security group for it. So you can open for both of these instances or open for one particular instance wherever you want to execute. Now, let me quickly open for both of them. How do you do that? Just go to the security group and edit the inbound configuration rules. Inbound, edit inbound. add rule. Just for the time being, let me just open all traffic because I'll anyways delete these clusters. So please don't take these practices very serious. And even when you are explaining during the interviews, don't say that I have opened all the traffic. Now let's try to access this. Go to advanced, accept risk. So you will notice that the Argo CD user interface is up and running. Perfect. So we have our half of the job done. That is, if we try to draw what exactly we want to do. So we need 3 clusters as per today's video. We got 3 clusters. Hub cluster is available. Spoke 1 is available. Spoke 2 is also available. So this particular part is done. Then I want to install Argo CD in this. This is also done. Now let's try to log into this particular Argo CD instance and verify if we are able to log in or not, because we also have to do that, right? After that, we will try to add these 2 clusters to Argo CD. So we are completed with step 1, create 3 clusters. Then step 2 is install Argo CD. That we have done. Step 3 is verify login. Now let me show you how to perform the login. The initial password is actually stored in this particular secret, kubectl get secrets -n argo cd. So there is this particular secret called initial admin secret. So what you can do is kubectl describe secret -n argo cd, and as you describe, you will get this particular thing. Oh, okay. You cannot do that. So just go here. Instead of describe, just do edit. And copy this. What you will do is after copying, echo this pipe base 64 hyphen decode, because by default they are base 64 encoded. So base 64 decode, and do not copy this ampersand, right? Leave this ampersand, rest all is your password. So go back, enter username as admin and password as what you got. Again, I'm repeating, do not copy this ampersand that I have shown. If this is your password, ignore this particular field. You can also do echo so that this will move, or you can pass argument to base 64. So my Argo CD user interface is also available. That means most of the things are working fine for me. Now the next step in this particular process would be, where is the drawing pad? So the next step in this process for me would be to add clusters, right? Because I want to deploy from here to here and here to here. So let's see how to complete the add process. And here comes the most important one. People find it slightly tricky, but I'll show you in a very simple way. If you go to the Argo CD user interface, you have a settings button, and in the settings button, you have clusters. So here you can see what are the clusters that this particular Argo CD instance can interact with. Let me increase the font size. So in cluster means the same cluster where Argo CD is already available. That means now this particular Argo CD instance that you have installed is capable of deploying resources on the same cluster, right? Because every Argo CD instance is automatically capable of deploying resources on the same cluster because it supports standalone. Now we have to add these 2 clusters. For that, you cannot do it using the user interface. Argo CD user interface does not support adding clusters, but you can delete the clusters, right? That is because of complexity. If you want to add cluster, you have to support or you have to provide a lot of fields, and through user interface, it's not possible because of some security reasons as well. So how to do that? There is something called as Argo CD CLI. So just search for Argo CD CLI download, and you will find, depending upon your distribution, if you are on Windows, if you're on Linux, if you're on Mac, you can use your own distribution. In my case, I can simply run brew install Argo CD. And if you are on Linux, please use this particular command. So I'll just run brew install Argo CD. Of course, I already have it, but just to show you, and the same thing happens if you execute this as well. The Argo CD gets installed. Perfect. It says Argo CD is already available and it's set to the latest version. So you're all good. Now comes the most important command where I need to add these clusters. For that, what I need to do is execute Argo CD cluster add. This is the command. And I need to pass few parameters where I already have it. And just say Argo CD cluster add. Yep. Argo CD cluster add. This is the command where the command is very simple. I'll debug this for you. So first, just say Argo CD add cluster. And the next thing that you will do is pass the context in the kube config of the cluster that you want to add, right? So I've shown you how to check the context. Again, let's run that command. kubectl config get context pipe grep us west1. Now you'll get 3 clusters, right? Out of which the hub is already added by itself. That particular Argo CD can already deploy to hub. Now this is the second one. Let's just copy this and say Argo CD cluster add pass this particular thing, right? Just copy paste whatever you see here. I have copied, I have pasted, and post that just pass this command called --hyphen server. That is to this particular Argo CD, you are telling what is the server's IP address. That is this particular address. So this is the one. Just copy the IP address followed by port. So I have copy pasted, and as I execute this, I will run into error. Of course, it is asking yes or no, but it will throw an error because I haven't logged into Argo CD through the CLI. I have logged into Argo CD through the user interface, but I also have to log into Argo CD from the command line. For that, again, I will run Argo CD login followed by this particular address. That is your Argo CD API server address. Again, you need to provide the same username and password. So username is admin and password is the one that I got from base64. Where exactly is it? So base64 --hyphen decode. No, this is not the password. Let's get it from edit secret again. Copy. Echo this base64 --hyphen decode. Just copy it. And what I'll do is paste it here. And my Argo CD login will be successful. Now I can go back and execute this command called Argo CD cluster add. Again, I'm breaking this command for you. Argo CD cluster add followed by the context of the cluster that you want to add, followed by the server address of your Argo CD. So I want to add spoke cluster 1. So I've added its context. Click on the enter. Why? Now it will take probably 10 to 15 seconds. And after that, it will add your Argo CD. Cluster is added successfully. Amazing. Now in the same way, let's add the second cluster as well. For that, again, we need to get the context. So get context. Now this is the one that I want to add. So Argo CD cluster add followed by this context followed by the IP address. Yes. And this cluster will also be added. So this is part where people find it little tricky. but it's very, very simple if you know how to use these commands in the same order. Now this cluster is also added. Now let's go to the Argo CD page and let's click on the refresh button. We should see 3 clusters. Awesome. So we have 3 clusters here. Now this Argo CD is all set to implement the deployments. Now all that we need is a Git repository where the Kubernetes manifests are available. After that, just a click of button and the deployment will take place. So now let's proceed with the GitHub repository. We can pick up any GitHub repository and it will deploy to all of these. Now let's proceed with the final stage of this demo, that is the deployment part. And what we are going to deploy. So again, I have a sample application. Today I tried again something different. Previously we deployed 3-tier architecture, we deployed Nginx, lot of things. And today we'll deploy a simple guestbook application where I have a deployment file, service file, and a config map. Using HubSpot model, using this Argo CD instance that we have, right? So this is the instance that we have spinned up. And using this, we will deploy onto the 2 spoke clusters. For that, what you need to do is in the logged in Argo CD instance, click on create application button. And here you just have to provide few details. These are very, very minimal. Like you just have to say what should be the name. Let me call this as test or test demo. What exactly is this file? If you are confused, you can correlate this with Jenkins. It will be easy to understand. So when we want to implement CI using Jenkins, what we usually do is we write a Jenkins file in Groovy scripting, or Jenkins also provides a way where you don't have to write any script. You just have to provide few fields in the user interface and it will create a Jenkins configuration file. And what this does is once you create this is basically your Jenkins pipeline. And if someone makes any changes in the Git repository, so this pipeline automatically will detect and it will execute the CI process. Argo CD also does the same thing where Argo CD comes in the CD part, and here you don't even have to write any Groovy scripting or something. You can go to the Argo CD UI as I have shown you, right? You can just go here, provide few details, just like you just provide like 5 to 6 details, and it creates something called as Argo CD application. And this Argo CD controller does the same thing. It will watch for the Git repository that I have shown you. So this will be my Git repository where these are my manifests. And as soon as this particular application is created by providing the 5 to 6 fields, it will deploy all the resources onto the multiple clusters you have. So that's what I'm going to do. Just provide, you can give any random name. You can also just say it as guest book because I'm deploying a guest book application. Project, leave it to default. Sync policy, set it to automatic. And repository name, just go back here, copy paste this repository. And then select the path. Path should be, if you go to your repository one more time, so this should be your path, manifest guest book. So you can again copy it from the browser and paste it here. Destination cluster is the key role. So in the destination cluster, to which cluster you want to deploy? So here you cannot provide multiple clusters at once. So what you need to do is for the first cluster, provide this one. So remember that I have provided 7F8 and provide the namespace. Let me put it in the default namespace. I'll just deploy all 3 manifests in the default namespace, right? All of these 3 manifests should be deployed in the default namespace of the spoke cluster 1. So just click on the create button. Now again, you have to do the same thing to spoke cluster 2. Let's see, there is some error. Okay, repository is not accessible because there is a reason. Currently my repository is a private repository. So what I'll do is I'll just go to the settings button, scroll down and just change the visibility to public. So right now I was writing the documentation, so I set it to private. So let me just change it to public. Perfect. Now this repository is public, so you can also handle private repositories. There is no problem. But for handling the private repositories, the process is slightly different. I'll tell you in future videos how to handle the private repositories as well. So this is for the spoke one. And now let's click on new app and set this. Like I told you, this is just one-time process. So let me call it as guestbook 2, project as default, sync policy as automatic, repository name as, what was the repository name? Let's go back. This is the repository, copy paste. So if you ask me, Abhishek, is there a way where I don't have to create multiple applications? Yes, that will be the next videos where we will learn about application sets. So application sets is another concept where you don't even have to write 2 applications, 10 applications, 100 applications if you have 100 clusters. So you just write one application set and it will generate all these applications automatically for you. So that will be our next video. But let's go step by step because it's also not good to learn everything in one single video. Manifest, guestbook, destination. Now let us select this particular cluster. So application sets is a very simple concept. It is just generating multiple applications. So the whole concept is what you're learning today. Probably application sets I can just teach it in 10-15 minutes because it just has multiple generators. And if you know this particular concept, it's very easy to understand that concept. So now you see, as soon as I created this application is already deployed, it says synced. So if you see the green button here and healthy, that means the guestbook config map is deployed, service is deployed, and the deployment is also deployed to the spoke cluster one. And if we go back, now this is also done. Guestbook config map is deployed, service is deployed, and deployment is deployed. So Abhishek, I want to see that, okay, you have deployed and you said this is one-time activity. Now let's go back to Git and change something. Yeah, we can do that. Just go to Git here, move to config map, right? Okay, firstly, let me show you. If we go to spoke cluster one, right? So let me switch the context so that it becomes easy for everyone. So kubectl config get context pipe grep US best one. Like you might say that, Abhishek, firstly, I want to see if this application is deployed or not. So yeah, you can copy the spoke one. You can do the same thing to spoke two as well. So I'll do kubectl. Let me just say config use context and this. If you have something like K9s or something, it becomes even easy to switch between the clusters. I have K9s, but I don't want to complicate it. Perfect. Now the context is switched and now I am on spoke cluster one. So if I just do kubectl get all, you will see the deployment, you will see the service, and you will also see the config map. All of them are deployed on this cluster. See, there is a service, there is a deployment, and for the config map, you can just do kubectl get config map. This is the guestbook, this is the config map. Now let's do the next level where I will just show you kubectl edit config map, and you will see that the properties value is actually set to, see, this is the file name which says UI properties file name is user interface properties. That is because we have the same thing in the Git repository. Now let me edit this and let me just change to from user to Abhishek, and let me click on the commit button. As soon as I do it, you will notice if you go to the Argo CD page, right? And if you just refresh it. So auto sync basically happens in a particular timestamp, right? So you can click on sync apps so that all the applications get synced, or you need to wait for 3 minutes. Auto sync happens every 3 minutes, but here we don't have time. So what I'll do is I'll do it manually. So now I have synced. Let me go back to the cluster. In production environment or in your environment where you have implemented Argo CD, you don't even have to click on this sync apps button because like I told you, this can be configured through webhooks, or you can wait for 3 minutes because by default the time period is 3 minutes. Or you can configure it for 10 seconds, 20 seconds. But please do not do that. When you have more number of applications, Argo CD will take little time to sync. So keep the value as default. Now let me edit the config map, and kubectl edit config map one more time, and it should reflect as Abhishek interface properties. Yes. So just wait for a couple of minutes if you want to see this automatically. In your case, like Abhishek, I don't want to click on that button. Yeah, you can do that. The CD process is completely automated, but just wait for 3 to 5 minutes. Perfect. And now what I'm going to do is I'm going to show you what happens if I manually make this change. Where, okay, Abhishek, you said Argo CD or GitOps will auto heal and it will not allow any change that I make manually. Let's try to see that. Where I'll click on this button, kubectl edit config map. And what I'm going to do is I'm going to change this back to user interface properties, right? I've changed this to user interface properties and click on the save button. It says config map guestbook is edited. Perfect. Now go back to the Argo CD user interface and you will see that guestbook is already complaining. It is already telling you that there is something out of sync, right? So this is how Argo CD or the GitOps will notify you that there is something out of sync. And what you can do is, like I told you, you can either manually click on this button called sync and click on the synchronize, or there is an option if you go back to the applications page where there, like when you create a new application, you can provide this option called auto heal, which will set this particular sync button automatically and you don't even have to click that. Like in our case, I have clicked that button. See, apply out of sync only, or you can just go through these fields where there are multiple options. But in our case, what I've done is I oh, it was manual written anyway. And if you go back to the cluster and try to see kubectl edit config map, now the change that you have made is revoked. Now the change is back to Abhishek. So what is happening? Argo CD is detecting any particular thing. You can change this 100 times, you can change this 200 times. And whenever you do that, the administrator or the DevOps engineer will quickly see out of sync option here. And this out of syncs will let DevOps engineer know that there is some change. Either you can wait for some time or you can automatically click on sync apps button so that the sync is done, right? So this is two options that you have. Either you can manually get it done or wait for some time so that Argo CD reconciles the change back using the auto heal mechanism. So this is the demo. And like I've mentioned, you can have 10 clusters, 20 clusters, 100 clusters. It doesn't matter. Today, we have seen it by using the applications feature that is available here. And in the next video, what I'm going to show you is application sets, which is slightly like a wrapper over this applications. And when you write one application set, all that you need to do is you just provide your your Kubernetes addresses, and it will generate all of these applications. Now, what is the difference between this application and this application? Only this particular field, right? The destination cluster field. So that destination cluster field is automated. It's like a loop is generated. Application sets will generate that loop and creates this application tiles that you're seeing here, or these applications. If there are 100, 1,000, doesn't matter. That we will learn in the next video. But for now, I hope this particular demo where deploying applications onto multiple clusters is clear to you. Thank you so much for watching the video. See you all in the next one. Bye.